Sir,
Can you complete the following statement such that is valid? A line drawn from the center of a circle perpendicular to a chord. What is missing here?
the
piece.
I got no idea.
Can you complete the statement, Pisa?
The line drawn from the center of the circle perpendicular to the chord bisects the chord.
Yeah, it bisects the chord. It means it's going to cut the chord into two equal parts. So this is the theorem. It says if we have a line from the center perpendicular to the chord, it's going to bisect the chord. Now, guys, this is also important. Sometimes they do this in some of the questions. They will give you a statement and ask you to fill in whatever is missing. So yeah, the only thing that is missing here is the bisect the chord. So we're referring to the following theorem here. A line drawn from the center of a circle perpendicular to the chord. So this is the statement which is missing. Can you see the part here?
Yes.
Yeah, it bisects the chord. So you should be able to fill in whatever is missing in a statement. And then let's start with our activity for today. So here we say it bisects the chord.
Yes.
Now, we're going to be given a diagram with statements. And then if you are given a diagram with statements, I think the first thing that you will have to do here is to try to go through the statement and then highlight it on your diagram and then add whatever is missing. If it's stated on the statement, but it's not on the diagram, so you'll add it there. So let's go through that. Mohau, can you take us through the statement here? I will just highlight whatever it is that you are saying.
They say OE is perpendicular to AB and EB is equals to 7 units and OE is equals to 24 units and DF is equals to FC. Therefore, it's equals to 15 units.
Okay, so let's
question 3. Please there.
So we need to determine with reasons. Okay, let's highlight whatever it is that is stated here. So the first thing that they gave us is that we have OE, which is perpendicular to AB. So we have this line, which is going to be perpendicular to this line. And then we have EB, which is equal to 7. So we are told this one here, it's given. This one here, it's 7. And then we are also told that we have, so I'm just checking if the statement, whatever statement is said here, it's also on the diagram here. Said we are told this one here is 24, so it's there. And then we're also told that DF is equaling to FC, which is equaling to 15 units. As you can see here, 15 units is written this side, but it's not written this side.
Yes.
So I will put the 15 also here to say this is also 15 because it's given. It's written on the statement, it's not shown on the diagram here. So that is going to be the first thing that I'm going to do. Now, guys, with these questions here, what we need to understand is the following. We're going to be using right angles, triangles to solve this type of questions. And then we're mostly going to be using theorem of Pythagoras to solve them. So I'm aware that you know how to use the theorem of Pythagoras. I'm not even going to go through that one. But what is important here are the steps that we're going to take so that we can use the theorem of Pythagoras. So I divided the question into two parts. There are going to be things that are given, and then there are things that we're going to add on our diagram. And then to make sure that you don't confuse yourself, make sure that you use different colored pens. So guys, it means that you'll have to buy colored pens there. So for the given things, you can use a red color. I think we can get a red pen. That one is going to be simple to get. And then you can also get yourself any other color, green. I think we can also get green. So the red one is for the things that are given. Is it fine?
Yes.
And then we're going to use the green one. The green one is going to represent the things that are not given, but we can add them on our diagram. They are not given, but we can add them on our diagram. Now, for example, one thing that we need to understand about these diagrams is that basically their ultimate goal is to look something like this. Any line drawn from the center to a circumference, the ultimate goal is to bisect the chord and also to be perpendicular to a chord. So it wants to have both of these things here. But if we look at our triangles here, you will realize to say that in each of them, there's something which is given and then something which is missing. So let's highlight the first one, the first part. We have this side. If you look at the following diagram, forget about just the highlighted, the green one. What seems to be given and then what seems to be missing, such that, let's start with what is given here on this diagram here. What do you think it's given?
That is equal to 90 degrees.
We are given that E is equal to 90 degrees. Ne?
Yes.
Now, in a theorem form, this is us saying a line drawn from the center is perpendicular to a chord. So I can say I'm given, I'm going to say in this diagram, I'm given a line from the center perpendicular to a chord. So that is what is given. Okay. And then let's go to the next diagram. On the next diagram, let's check on this one here. Also going to be highlighting it with a green thing now. This diagram here. What seems to be given on this diagram here?
That D angle FD equals to FC.
So we are given that we have a line from the center. So if I consider this line from the center, so you do have a line from the center to the midpoint of a chord. So I will write here, I'm given a line from center to midpoint of a chord.
Yes.
Okay, now that I've written what is given, the next thing that I'm going to do here is to add what is missing, such that each of the diagrams that I've highlighted, it has all these things here.
Yes.
Let's check who else is here. The others are quiet. Lifa. Lifa.
Oh, yes, I'm here.
So let's look at the following diagram. If you look at the following diagram, we want our diagram here, this one here, to look like that one. What is missing on that diagram such that it looks like this one? Lifa. Lifa, are you here? Amu?
Sir?
It seems as if Lifa network is troubling him. What's missing here on this diagram here? So that we can have it look like that one.
The line showing that EA equals to EB.
Equal signs.
Equal sign. Okay, so this, what is missing is that this is going to be equal to this. Nah? Okay, now that we've added it, I will write it because I'm adding this. So I will write AE is going to be equaling to EB. And then when they ask me why am I saying that, I'm going to quote the given reason here. I already wrote what is given.
Line.
Yeah, so the reason why we have AE being equaling to EP is because we have a line from the center perpendicular to the chord is going to bisect the chord.
Yes.
Are you good then?
Yes, I'm good.
Okay, let's go on to the next one. If we look at the top diagram, let's look at the top diagram. Now, let's concentrate on this one here. What seems to be missing on this diagram such that it's going to look like this one? What is it that it doesn't have? Yeah?
90 degrees.
It doesn't have the 90 degrees. So we'll add the 90 degrees. And then as you can see, because I'm adding things, I'm using the green pen. The green pen is for adding things that are not there. The red one is for
things that are
writing
given.
things which are given. So I will put 90
Yes.
degree. And then if they ask me, why am I saying this is 90 degree? I will come and write here. This is going to be 90 degree. And then I will say angle
Share.
O F
Yes.
angle OFD is going to be 90 degrees. And then the reason why I'm saying this is going to be 90 degrees is because I have
a line from center to the midpoint of the chord.
Yeah, it's a line from the center to the midpoint of the chord. Okay, now that I'm done with that, I've written what is given. I've added whatever it is that is needed so that I can solve this diagram. The next thing that I'm going to look at are the line from the center. I'm going to check where does the line end? Does it go to the circumference or it goes to the chord? So I'm going to use a different color even for that one. So let's start with this line here. It's a line from the center. This one, it goes to the circumference again.
Yes.
Yes.
And then do we also have another line from the center to the circumference? I'm going to use the same color for lines from the center to the circumference. We have another line from the center to the circumference?
Yes.
Yes.
Which line is that?
OC.
OA.
OA. Ne?
OC.
We don't have
Yes,
OC. OA. Ne?
Oh, yes.
Yes.
So I will highlight this one to say it should be blue. And then here, do we also have another line from the center to a circumference? I'm just checking all the lines from the center to a circumference. Do we have another one?
Yes.
OG.
OG. Okay, I will also highlight this one.
Oh,
Now,
Mr. We
guys.
are highlighting.
Yeah?
We are highlighting those that are given.
I'm highlighting lines from the center to the circumference.
Okay.
Yeah, I'm highlighting all the lines from the center to the circumference with the same color because they are all going to be equal. Why are they equal, by the way? So I will say to them, OA is going to be equaling to OD, which is going to be equaling to OG. Why are they equal, these lines?
Line from the center to the circumference.
It's because we have a radius.
Yes.
Yeah, all radius. So they are all equal because they are radius. A line from the center to a circumference, we call it a radius. No?
Oh, Mr.
Yes.
Equal radi.
Eh?
Equal radi.
Yeah, you can say radi. Yeah, that's the one. Equal radius. Yeah, you can say equal radi.
Okay.
We still fine?
Yeah, I'm fine.
Okay. Next. Now that I've highlighted all the given information, then I can start to work now. After doing this, then we can start to work. Now, the first thing that we want to do, we want to determine with reasons OA. So let's go and check where is OA. We need to check the diagram in which we are going to work in. Which diagram has OA?
Triangle OA.
It's triangle AOE. Can you see this one?
Mm-hmm.
So we'll use this diagram. Yeah, we'll use this diagram here. On this diagram, we should check if we have the 90 degrees. Obvious, this is 90 degrees. If this is 90 degrees, this one here is also going to be 90 degrees. And there is something that we said, because it's written in green, the green is going to tell me that this thing here, it's not given, but I need to say it. I know this one here is also going to be 7. And then the reason why I'm saying this one here is going to be 7 is because we have a line from the center perpendicular to a chord. So I will start there. I will say AE
equals to EB.
is going to be equaling to EB, which is going to be equaling to 7.
Center.
Yeah, and then we have
progress.
Line from
Center
perpendicular to chord.
perpendicular. Yes.
Okay, and then from here onwards, we can use this triangle. So we have triangle AOE. We're going to use in triangle AOE, so we'll have in AOE. Now we can take out the triangle so that we see what is it that we have, what is it that we don't have. So we know this is 90 degrees. We have O, we have A, and then we have E here. This is 7. This is 24. Not 24 degrees, it's just 24. And then we can use our theorem of Pythagoras then to get OE. So if we say we are looking for A,
Recording.
AO, all squared is going to be given as AE all squared plus OE all squared. Now, then we can move on from here. What is going to be our AE? Our AE is going to be equaling to
7.
7. So it's 7 all squared plus OE is going to be given as 24 all squared. Then we'll say AO all squared, then we flip both sides. It says AO is going to be given as,
Yes.
if we type this in our calculator, what do we get?
25.
We get what?
25.
25. So we have plus and a minus 25. Now we are talking about the radius, and this is the length of something. So the length is always going to be positive. So we'll say this length here is going to be 25. Since they didn't give us any unit, we'll just write it exactly the way it is. We'll simply say 25 units. So that's the first part. And then we go to the next one. On the next one, we're looking for FO. Now, where do we get FO? We are going to check on our triangles to check where do we get FO. But here's the good news now. We know this one here is 25. I'm going to use the blue color again. We just got one of the blue to be 25. So if this is 25, it means this one here is also going to be 25. It means this one here is also going to be 25. And then there was the red color that we had. We said this one here is equivalent to 15 because it was given, using red to say it's given. Now we're looking for OF. Where do we get OF? We're going to get it in this triangle here. Now we'll say in triangle OFD. So we have in triangle OFD. What you're supposed to have here is you are looking for OF. You have the radius. You also have this side. So you're looking for OF. Then you will say OD all squared. So you say OD all squared is going to be given as OF all squared plus FD. All squared. Guys, why? It's like I'm alone now. Jane,
Sir.
you are here. What happened to
Yeah.
Are you still here? I'm talking alone. What is OF? What is OD?
OD.
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 25.
25. And then we are looking for OF, so we'll simply write it as OF all squared plus, what is FD?
15.
It's 15 all squared. And then if we take this one to this other side, it says we're going to have OF all squared, which is going to be given as 25 all squared minus 15 all squared. And then if we do that, what are we going to get?
400.
400.
It's 400. So OF
Yes.
all squared is going to be equivalent to 400. If we square both sides, we have a plus and a minus, and then it says OF is going to be equivalent to 20. Ne?
Yes.
It's 20 units. And then from here, we are going to take plus and a minus. Which one should we take, positive or negative? We're talking about the length of something. Positive or negative? Positive. So we say we have 20. Okay. So now that we got OF, the next thing that we're going to look for here is this. Last but not least, we're going to look for FG. Now, where do you find
Recording
FG?
in progress.
So we have FG here. Can you see that again?
Yes.
Yes.
But FG is part of the blue line. So FG is part of the blue line. Now, what do you know about the blue line? And then you already got this one. You got this one as 20 here.
25 units.
The blue line is 25 units. Ne?
Yes.
Then it means our FG, what is going to be our FG if we round this off? What is going to be our FG?
5 units.
So our FG is going to be equivalent to 5 units. Now, how did we get that FG is going to be 5 units? We said we can get OG by adding OF plus FG. But we know what is OG because OG, we said it here. OG is a radius, and then we already got one of the radius as the blue line. So this is going to be 25. And then we just calculated OF, which is 20, plus FG. And then this is going to give us, take the 20 to the other side, it says 5 is going to be equivalent to FG. Now, guys, with that being said, we can come and do the following activity. Let's quickly do this one, and then we'll come back